Hello, I'm Scholastic Sam. Welcome back to my YouTube channel. Today, in the topic of college hours, we will be going over interest, growth, and decay. So let's get started. There are three types of interest. The first is simple interest. The equation for this is A equals P 1 plus RT. A is the future amount, P is the initial amount, R is the rate of change, and T is the time in years. So it's pretty much saying we take the rate times time, add 1 because the rate times time finds the interest, and we have to add 1 because it's growing. And we don't want to get the interest, we want to get the actual amount. So we have to take the interest and add it to the initial amount to get the future amount, which is A. Let's try a practice problem. You get a student loan from the New Mexico Educational Assistance Foundation to pay for your educational expenses this year. Find the interest on the loan if you borrowed $2,000, so we already know P is 2,000, at 8% for 1 year. So T is also 1, and we see 1 year. Now 8%, that can be a little tricky because percent just means times 100. So to get a decimal, we have to divide by 100, and 8 over 100 is 0.08. So A equals 2,000, 1 plus 0.08, and because 0.08 times 1 year is just 0.08, plus 1 is 1.08, and times 2,000 is just 2,160. Compound interest. 2,160, and that the interest accrued on the loan is $160 because A minus P. Compound interest. Now, the idea behind compound interest is that they calculate your interest multiple times. So if, let's say, your interest is 2%, they multiply by 2% and then multiply by 2% again. That's not going to be linear. That's going to be exponential because you're multiplying by 2%, and then you're multiplying that new value you got, again, by 2%. So the equation for this is A equals P, 1 plus R over N, to the NT power. So A is still a future amount, P is still a principal amount, R is still an interest rate, T is still a time in years, but N is the times compounded. For example, if we have a certain amount and we multiply that amount by 0.2, and we do that 4 times, it was compounded 4 times. Let's do a practice problem. You put money in a savings account with an interest rate of 2% per year. They give you a special deal and say if you deposit $2,500 into your account, they will compound it monthly. How much money do you have after 6 months? So we see 2% per year, so we know our interest rate is 2 divided by 100 is 0.02. If you deposit $2,500, so we know our principal amount is $2,500. Time is 6 months, which is half of a year, so T is 1/2 because it's T in years, so the time is 1/2 of a year. But it's how many times it was compounded, and that N is how many times it was compounded during that time. If it compounds monthly and the time is 6 months, it will be compounded 6 times. So N is 6. So if A equals 2,500, quantity 1 plus 0.02 over 6 to the 8 times 1/2 power. Now 8 times 1/2 is just 4, and 0.02 over 6 is approximately 0.033. So we have 2,500, 1 plus 0.033 to the 4th power, which is just 2,500 times 1 plus 0.033 to the 4th power. When we take that to the 4th power, we get approximately 1.013, and when we multiply that by 2,500, we just get $2,533. Let me fix that there. Okay, $2,533. In case you couldn't see the answer, there's 21,600 on that last one. So let's now go to continuous interest. Now, continuous interest involves something called Euler's number. Now, Euler's number was invented as a way to say, well, what happens if you compound it continuously? Because the amount of times compounded, if you keep getting smaller, like 1 month, 1 week, 1 day, eventually there can't be any less time in between compounds, and thus it's just continuously being compounded. but it's not going to keep growing by a lot, because eventually it's going to be compounded so quickly that each time is such a small amount added that it doesn't really do much for you, that it's compounded continuously. So this is the equation for a continuous compound. A equals PE to the RT. A is still future amount, P is still principal amount, E is Euler's number, R is still interest rate, and T is time in years. And E is just it's a version of N, which is like how many times it's compounded, because it's continuously compounded, so it's not compounded a specific amount of times. So it's approximately 2.72, but in our calculators, we'll use the actual amount because it's more accurate. So let's see a practice problem here. Anita opened a savings account and deposited $100 in it, so we already know P is 100. The account earns 12% interest. 12 divided by 100 is 0.12, so their R is 0.12. It's compounded continuously, so this is a continuous compound. E is just Euler's number. If she wants to use the money to buy a new bicycle in 1 year, so T is 1, because times 1 year, how much will she be able to spend on the bike? So it's asking us for how much money she will have 1 year from now. So we have to find A. So A is 100 E to the, that's supposed to say to the power of 1, to 12 times 1. 12 times 1 is just 12, so we get 100 E to the 12th power. Now, it's not 100 E to the 12th power, it's 100 quantity E to the 12th power. So Euler's number to the, or 0.12 power, sorry, the 0.12 power. So E to the 1200th power is just 1.1275. And that times 100 is $112.75. And my mistake, it's something with PowerPoint. It's weird. It's like X up when I superscript things or make them like an exponent. But it says E.12. That's supposed to say, just supposed to say to the 0.12 power, or to the 1200th power. Well, thank you guys. Please like, subscribe, and turn on post notifications. If you have any questions, comments, or concerns, please leave them down in the comment section below. Thanks to my math teacher, Mr. Barrett, for teaching me this information. And please join us next time where we discuss natural logarithms. I'm Scholastic Sam. Bye. Oh, and always remember, knowledge is power.